All right. So I'm going to open this up. All right, so let's take a look at the README before we start anything. So here we're trying to learn to model systems with objects, use instance variables and accessing instance variables effectively. We want to work with objects in Python. So what we want to do is we want to create a toy program to model an apple tree growing over the years. We plant the apple tree, wait for it to bear some fruit, and then pick all the apples as soon as it does. The tests in apple tree spec show how this all might work together. So really 0 is implement the apple tree and apple classes. So set up your apple tree and apple classes with the appropriate attributes. You'll need to be able to call tree.height and tree.age to get a tree's height or age respectively. What other attributes might your class need? Use the code in the runner file to guide you. Write tests. Well, this is an older version. We're not writing tests. We already have a spec file here. So let's use this as our guide instead of the runner. So first I'm going to check out a new branch. All right, and then I'm going to use failfast to run some of my code. So I'm going to say Python apple tree spec -f. All right, we had one test that failed. The apple tree object has no attribute age. So I'm just going to keep on making this happen until, just keep on changing these things until it works. So it needs an attribute called age. Okay, so we can just say self.age equals 0 to start with. So that's what you start when you first start growing, is you're 0 years old. I'm going to run again. We have another error. Test age tree. 0 does not equal 1. So we take a look at apple tree spec. So we can take a look at it. It says when you create an apple tree, it expects the age to be 0. And then when you use the age tree function, it expects it to be 1. So pretty self-explanatory. Self.age plus equals 1. Just going to keep on doing this model of just keep on doing things until all of my tests pass. So now it says right here, apple tree object has no attribute height. Okay, we can set self.height also to 0. Run the code. All right, we have an assertion error. 0 is not greater than 0 in the test age tree height. So if I take a look at that test, it says, all right, the original height should be apple tree.height, which should be 0. When you age the tree, it's expecting tree.height to be greater than the original height. So interestingly, that it doesn't say that how much it has to grow by. It just says it has to get bigger, right? How high should our apple tree grow when we age it?
1.5 feet.
Sure.
Or 2 years.
Self.height plus equals 1.5. All right, we have another failure. All right, in test any apples, self.assert true, apple tree.any apples, none is not true. So it says right here, when you call the any apples method, it lets you know if there are any apples on the tree. So we can take a look. It creates an apple tree. Says that there shouldn't be apples on the tree when you first start it. And then it says use this itertools library to age the tree 10 times. And says there should be apples on the tree at that point. Okay, so since they aged it 10 times, let's just say we can just say, all right, maybe our apple tree should start bearing fruit at age 10. That makes sense, right? So we could just say if self.age is greater than or equal to 10. Actually, we don't even need to say do that if thing. We can just say return self.age is greater than equal to 10. And that'll either return true or false depending on what this thing moves out to be. So I run that. All right, is dead. None is not true. how old should our apple tree be when it dies?
At least 100.
Yeah, you could say return self.age is greater than or equal to 100. Okay. What questions do you have before we move on to other stuff? Are all these methods and attributes making sense so far? Okay. I'm going to run another test. It says right here, in apple tree spec, test pick an apple. So we raised an exception, no apples on your tree. So it says raise exception, no apples on your tree. So let's take a look at that method. It says when you call pick an apple method, it will return an apple object. So they create an apple object here, apple equals apple. Apple tree is a new apple tree. It ages the tree 10 times. And then it says self.assert equal, the type of apple tree.pick an apple is equal to type of apple. So like the text here says, we expect this method to return an apple object. So to do that, we'll need to code an apple object. So we have class apple def init. And if we look, I believe there was something that said that apple class needs to be implemented by this point, including apple and apple.diameter. So an apple should have a diameter. To do that, I'm going to use the random library. I'm going to say from random, import randint, because I want the diameter of the apple to be random. So I'm going to say self.diameter equals randint. Let's make it anywhere between 4 and 8. And then to add it to my apple tree, I'm going to have to say from apple, import apple. All right, so it says here, pick an apple, read the test before coding. So let's take a look at those tests again. So when you call the pick an apple method, it will return you an apple object. Okay, so let's just do that right now. Return a new apple. I'm going to comment this out. Just going to keep on running the tests until we need to change something. Okay. Now it says test pick an apple error, exception not raised. When you call the pick an apple method with a tree that has 0 apples, it will raise an error. So it shoots here, it says with self.assert raises apple tree.pick an apple. So we have this method here, any apples. So how can we make this so that our method here will raise the exception at the appropriate time?
If any apples returns true, then pick one, else raise exception.
Yep. If self.anyApples, we return an apple, else we raise the exception. Okay, we passed all our tests. Does that mean we're done? We also have that runner code to satisfy. So we have right here, we can take a look at our runner code. So this is all written for us. We create an apple tree. While tree.anyApples equals false, we age the tree. Then it'll print while my apple tree is producing apples at age blank and is tree.height feet tall. And then it'll say while tree.is dead equals false, we have create an apple basket. We say while tree.anyApples, apple basket.append using the tree.pick an apple method. Then we're going to need to write a method to calculate the average diameter. And then it'll print the tree's age, the tree's height, and it'll keep on doing that until the tree dies. Okay, let's try running this and see what happens. Uh-oh. So it looks like we've hit a snag. So I did a keyboard interrupt there. So it's let's try to figure out what happened here. So we created an apple tree that worked okay. While tree.anyApples equals false, print.age tree, fine. We got to line 8, print this. My apple tree is producing apples at age 10 and is 15 feet tall. Then we reached line 10, and that's where it seems like the problem happened. Now, let's take a look at my method here. Figure out why did that loop happen that it never broke out of.
Is it because at no point any apples is not equal to false?
Exactly. If we take a look, all any apples does right now is tells us whether it's older than 10 or not. And this loop says, while the tree has any apples, keep on appending that. So it's just filling the basket with infinite apples because we just said, hey, it has apples because it's older than 10 years old. So seems like our spec file here can only get us so far. I forgot that we had an apple spec file. Whoops. Okay, we don't need to worry about that. Anyway, our tree spec file here can only get you so far because you can pass all the tests while still completely breaking your code. So what should I do to my anyApples method to make sure that it doesn't break my code this way? Let's think about this in terms of real life then. In real life, how many apples does an apple tree grow per season? If you had to guesstimate.
Like
50.
80 to 120?
80 to 120? Yeah, we can do that. So we need a way then to say, okay, any apples shouldn't just return the age, it should also return whether or not we have apples on the tree. How can we represent the number of apples on our tree?
Would you need an array or something that holds the apples that it's producing?
We could do that. So we could make something like self.apples equals an array. And then we'd want to make sure that the tree adds apples to it after it reaches a certain age, right? What method is probably the best place to do that in? We have methods here. We have age tree is dead, any apples, pick an apple. At what point in this process should we add apples to our array?
Age tree.
Age tree.
Yeah. So we could say something like if self.age is greater than or equal to 10. Then we could say something like we can import the randint method again. If we want to randomize the number of apples we get. So we could say, so for I in range, randint between 80 and 120. We could say self.apples.append a new apple object. Does that make sense? Does this method work the way we think? Does it look like this method will work?
I mean, it's going to keep on
adding apples to the tree every time.
Mhm.
So like by 20, it should have like 1,000 apples.
Yeah, so maybe we should say, like before it's, maybe before we add apples, we empty the apple array. So we could say something like self.apples. Is there a method to just remove everything? Or do we just have to .clear, I believe we'll do that. And then we append between 80 and 120 apples. So that way our apple tree doesn't get a ridiculous number of apples on it every year. Okay. And then our any apples method should work a bit differently then, right? Because we don't, in this case, we're not really worried about the age. What are we trying to determine? Whether or not there are apples on? How can we determine that? How do we know that our tree has apples?
Length of your list array.
Yep. So we could say return len of self.apples is greater than 0. All right, and there's one more thing we're going to have to do because our pick an apple function right now just says if there are apples, we return a new apple object. That's not going to empty our array, is it? So we could do something like, what's a method that we could use to get rid of an apple in our array?
Pop.
Yep, pop. So because return self.apples.pop. Because what .pop does, it removes the last thing from the array and returns it. So we're returning the last apple from the array and removing it from that array at the same time. All right, what questions do you have about this method? About what we just did, that is.
Hi, Noah, it's Gio here. Like, I just got a question right there, like at line 14. Like, I'm a little bit confused when you do like the for loop and you choose like apples between that range. I don't see that you use like the item right there, the letter I.
Yeah, sometimes you don't. Sometimes you don't have to use it. All I wanted, the reason I said this for I in range is I'm trying to, by creating this for in loop, I'm just telling it I need this to repeat so many times. Whether or not I use this, it'll still repeat and do whatever I'm doing here every single time.
Oh, okay.
Yeah.
Makes sense now.
Yeah. And like some languages have something that just says like repeat this many times. But I think with Python, you need to use a for in loop if I'm not mistaken.
Okay, thank you.
No problem. All right, let's try it. So we could say Python apple tree runner. Okay, let's see. So we can kind of take a look. It gets to 10 years old, 106 apples with an average diameter of none inches. Okay, so we still have some work to do. But we can see the apple tree is growing, it's producing apples. Okay. That looks pretty good. So the last thing we'll need to do then is create this average diameter thing, right? So you need to change this so that it is calculating the average diameter of all the apples in the basket. Okay. So how do you calculate average before we even get the code of this? Like mathematically speaking, how do you calculate the average of a bunch of numbers?
Sum numbers and divide by the number of numbers.
Yep. So we need to get the sum of all the diameters and divide by the number of apples. All right, so the first question is, okay, how do we get the sum of all of the apples? Of all the apple diameters, that is. What's something we can do for that? Because we have this apple basket array that at the end of this is going to be filled with between 80 and 120 apples.
Iterate over the apples in the basket.
Yeah, say 4 apple in apple basket. And maybe we want to make a collector to hold all, like, so we can get the sum of all the diameters, right? Say like total diameters. Excuse me. We could say total diameter plus equals apple dot diameter. So that should give us a sum of all the diameters of all the apples in the basket, right? All right, so then we need to calculate the average diameter. How do we do that?
Divide by length of the basket.
Yep. So total diameter divided by LEN of apple basket.
And we'll need to case somehow whenever the length of the apple basket is 0. I was getting a divide by 0 error whenever I did it the first time.
Okay, yeah, so we can always say, yeah, if the program is working right, the apple basket should only be full when this runs, but we can also make sure, that we can say if len of apple basket is greater than 0, just to be safe. All right, let's try it out. All right, so we have 114 apples with an average diameter of 6.10526. Keeps on calculating the average diameter. Okay, how's that look to everybody?
Your tree gets really tall.
It does get really, really tall. And they didn't tell us not to make the tree get really, really tall. So, if we wanted to edit this for realism, we could definitely say, tell it to stop aging after a certain height, stop growing after a certain age, for example. What questions do you have about the relationship between the apple tree class and the apple class? Kind of makes sense how we did this?
Are you gonna post that anywhere, Noah?
I can.
Or
Yeah.
just the video? Okay.
If you think that would be helpful, I will definitely post it. One thing I do want to kind of take this moment to talk about is in coding, there is a concept called the Law of Demeter, which is it's a cool name, and it's a principle that is it's a design philosophy, I should say, for object-oriented programming. And the simple, in a nutshell, it means that when your objects interact with one another, they should know as little about one another as you can possibly make it. And this case, the apple class doesn't know anything about the apple tree class whatsoever.
No.
Nope, not a thing. And how much does the apple tree class know about the apple class?
Just that it exists.
Yeah, just that it exists and that you can instantiate a new apple. using this, you know, in the standard way. It doesn't take arguments. And the reason that this is a thing is there's a principle that we want to stick to, kind of called the principle of least privilege. Essentially, you want to make sure that each part of your code only knows as much as it possibly, like the minimum it needs to know in order to function. And the reason we do that is if we make the apple tree and apple class too deeply entwined, if we change one, then we need to change everything about the other. So the less that these two classes know about each other, the more we can change one of them without worrying about the other. And so that's something we'll be checking for as we go forward with more object-oriented programming, is that you know, principle of least privilege and the law of Demeter. So just keep that in mind as we go forward. What other questions do you have about apple trees? Okay. In that case, let's take a 6-minute break. So be back here at 9:06, and then we'll get started with ice creams and freezers.